Okay, 3.2, we are switching to radical equations, and it's a lot easier than rational, but we're including this because we still have to check for extraneous like we do rational equations. So first step is isolate the radical on each side of the equation. So a radical, just a reminder, is a root. It can be a square root, a cube root, and really any index number. That makes it a radical. So step one is isolate. That means make it be by itself on one side of the equation. So right now, our radical is not isolated. Do you see what needs to be moved to the other side of the equation? Yeah, we got to add 2. Now we have square root of x squared plus 4 equals 2. Now it's isolated. Now just on the left-hand side of the equation is the radical. Okay, step 2 is raise both sides of the equation to the power of the index. So on a square root, you can't see the index, it's a 2. So what we're going to do is we're going to square both sides. So I'm going to square this and square this. So what that does is it makes the square root go away. Yay! Just like the least common denominator made the fractions go away. So I'm left with what's underneath x squared plus 4 equals 2 squared, which is 4. Okay, last step is solve the new equation. So we're going to get x squared by itself. We're going to minus 4, minus 4. So this one's x squared equals 0, square root. So this one, x just equals plus or minus 0. We would just say x equals 0. And then our last step is to check for extraneous. So that means we go plug it back in and make sure everything works out okay. So we have the square root of x squared plus 4 minus 2. And that should equal 0. I put the whole equation in, but what's x equal? We're going to change it. X equals 0. So does that equal 0? Yes. So x equals 0 is our solution there.